In this lesson, we're going to be looking at rational exponents. Rational exponents are just another way of expressing a radical. So for that reason, you should never have a rational exponent in the denominator. You should rationalize the denominator. All right, so to convert a radical to a rational exponent, you need to take the index. The index goes in the denominator of the exponent, and the power for the radicand goes in the numerator of the exponent. For example, the cube root of 4 we can write as 2 squared. So the comparable expression written as a rational exponent would be 2 to the 2/3 power. X to the 4/3 power would be the cube root of x to the 4th power. So anytime an exponent has an even number in the numerator, the value of the base can be either positive or negative. So for this example, we have the 7th root of negative 128. So to simplify that, we want to first write the radicand as an exponent. So negative 128 is negative 2 to the 7th power. And then the 7th root of anything, well, the way that I would write that as a rational exponent would be negative 2 to the 7/7 power, which 7/7 is just 1. So we just get negative 2. And then to simplify this one, again, we want to just write it as a rational exponent. 125 is 5 to the 3rd power. And then m to the 9th is m cubed to the 3rd power. And to the 30th is n cubed to the 10th power. And again, in order to bring anything out from up under the radical sign, I need to have whatever the index is, number of those factors. So if the index is 3, I need 3 of those factors in order to pull that term or number out from up under the radical sign. All right, so I can pull out a 5, I can pull out 3 m's, and I can pull out 10 n's. In this example, this is a square root, so the index is 2. So I want to count the number of pairs of factors that I have. 36 is 6 squared, and then x to the 4th is x squared to the 2nd power, and then y to the 6th is 3 y squareds. So I can pull out a 6, I can pull out 2 x's, and I can pull out 3 y's. Here we're looking for groups of 5 to 24. We want to do a factor tree to find out what all the factors are. So 224 is 2 to the 5th power times 7. And then r to the 8th power is r to the 5th power times r cubed. So I have 5 2, so I can pull out a 2 from up under the radical sign. There's only 1 7, so it stays up under the radical sign. I have I have 5 r's up under the radical, so I can pull that out from up under the radical sign, and I'm left with 3 r's up under the radical sign. All right, so we want to put this in exponential form. So again, the index goes in the denominator. The power of the radicand, or the outermost power, goes in the numerator. All right, so I want to rewrite that into the 5th root of n as n to the 1/5 power. And when I raise a power to another power, I multiply the exponents. 1/5 times 4 is 4/5. Same here. Rewrite the 11th root of p to the 6th. I want to rewrite the 11th root as that quantity to the 1/11th power. And then I just multiply the exponents, p to the 6/11th power. Same here, write down the radicand, and then rewrite the 6th root as that quantity to the 1/6 power. And then all the factors inside the parentheses is raised to the 1/6 power. So we have 10 to the 1/6 power, And then k cubed raised to the 1/6 power is going to be the 3 times 1/6, which is 3/6, which we can simplify to 1/2. And then first thing we want to do here is rewrite that radical as an rational exponent. So we should have 5n to the 1/3 power. Multiply those exponents. 1/3 times 2 is 2/3. And then raise everything inside that parenthesis to the 2/3 power. And then just leave it in the denominator just because we don't want to write it as with negative exponents. And now we want to go in the reverse direction and write these rational exponents as radicals. So we want to raise 7 to the 5/2 power and k to the 5/2 power, or the denominator of the exponent is the index of the radical, and then the numerator of the exponent is the power for the radicand, 7k. All right, so we have a square root and then 7k to the 5th power. Except we don't write the 2 for square roots. All right, and then just raise everything in that radicand to the 5th power. So we can calculate 7 to the 5th. 7 to the 5th power is 1,680, 16,807, and then times k to the 5th power. All right, so the 7 is in the denominator, so that's our index for the radical. And then 6 is going to be the power for the 3a. We want to raise the 3 to the 6th power and the a to the 6th power. 3 to the 6th power is 729, and then times a to the 6.